So I wanted to make a video on interfaces because it's a kind of a complex topic because it's something that is used in Java for many different things. So if you jump onto Google and you say, what's the difference between an abstract class and an interface, you'll have like 7 different answers. And so just wanted to bring some clarity to that. So then first of all, what is an abstract class? An abstract class is one where you possibly have methods that are not defined. Right? So you just have the signature. And so an abstract class is one where you cannot create an object of that class because not all of its methods are defined. Right? So then we also have the interface. And the interface is very similar to an abstract class. The only difference is that the interface cannot have any instance variables, and all of its methods must be undefined, right? So so an interface is kind of a subset of an abstract class. You can have instance variables here, but they must be static and final. So final meaning that it doesn't change, so it's like a global variable that doesn't change, constant. Static meaning that it's associated with the class. So if this was interface horse, what you can do is you could just say horse dot variable name, right? Anywhere in your program that uses this interface, and this will be valid and good to go. So yeah, I'm not too clear on the different ways you can use the static final variable. But let me just speak on a couple of the differences between abstract classes and interfaces. The first thing is abstract classes are used to build a hierarchy. So I'm going to just signify hierarchy with this little symbol. Here between family, between what can we say? Classes in a family. In a family. So something that would fall in line here would be insect as the abstract class. And then down here we can have cockroach and we can have butterfly. So here we have a family because there's an insect, and a butterfly is an insect, and a cockroach is an insect. Here in the interface, what it's used for is to build a relationship between classes that, no, let me put here, between separate families. So for instance, if we did have that insect abstract class that had the cockroach and the butterfly, and then we had over here, I'm not even sure, maybe we could have a car class. And here we can have a Hyundai, and over here we can have a Toyota. Well, what about if we wanted to build a connection between the two? Then we could build an interface that would connect the two. Like perhaps we're building a simulation on insects and their wanderings around the city, and in the cars we're doing the same thing. So then we could build an interface and connect those two pieces of data, and then provide an analysis. So abstract class would be again creating a family tree, and the interface would be connecting those two separate family trees. All right, what else? Interfaces are used to.
Oh, my head, dude.
So that's one aspect, right? Another aspect is that interfaces are used to build systems, right? Well, along with abstract classes. Could have an abstract class, could not have an abstract class, optional. But then the fact is that if you're designing a system and you want to be sure that everybody's on the same page, you could build a set of interfaces, a set of abstract classes, define certain methods that you think would be helpful and useful, and then give it to your, your team, and then you can be sure that everything's going to fall in line. Like you can care less about the implementation. You don't really care. All you care about is that it works and that it receives the right input. The methods receive the right input, and they give you back out the right, the correct data that you're expecting. What else can we use the interfaces for? We can use interfaces to implement a set of methods on an existing system. So one project that I wanted to have us do, but we don't have enough time, and I'm kind of changing the structure of the class so it doesn't fit in, is an Elon Musk like enterprises class structure. So what I had here was the SpaceX. SpaceX, if you're not familiar with them, it's Elon's I don't know like newest venture where he's sending out satellites into low Earth orbit, like a whole network of them, and they're going to provide broadband service um, where there's no, you know what I mean. There's no need for connection, right? So this opens up the possibility to free internet anywhere at any time, right? In the middle of the Pacific Ocean, the middle of the Congo, in the middle of the Peruvian jungles, right? So SpaceX SX. So each one of these represents a satellite, and let's say we have 4,000 of them. We also have the Teslas, and I think there's 125,000 of these guys out. So if Elon Musk Enterprises has these two fleets, he has their satellite fleets, he has a Tesla fleets, and he wanted to analyze for whatever reason. You let your imagination loose on the reasoning, but for whatever reason, he wanted to analyze the amount of energy that's required to maintain the satellites and the amount of energy that's required to maintain the Teslas. What can he do? He can build an interface that both of these are going to implement, and in the interface, he can have a method called energy out. Right? So then this is going to give the interface. What's going to happen is you're going to create an array of type E of this type of interface. You're going to implement in the Tesla and the satellites. You're going to drop all of the objects into the array list of type E, and then you're going to have a for loop you're going to have a for each loop that runs energy out and keeps track of all the data that's coming in from the different objects. So that's another way that you can use interfaces. Lastly, interfaces can be used to implement multiple inheritance. And to demonstrate this, I'm going to do a race. And so I went to college and I studied computer science, and the language that we used was C++. And C++ is kind of you're given all freedom, right, to do whatever you want. With inheritance, you can inherit from multiple objects. So if I had like an insect and I had the car, and I had a new class that I made, so this is the new class, I can inherit from insect and I can inherit from car. Right? So I'm inheriting all of their instance variables and all their methods into a new object. So that doesn't make sense sometimes because you can't have an insect and a car be the same thing. So C++ gives you a lot of freedom, but it also gives you a lot of freedom to create a design that makes absolutely no sense, right? So it gives you the freedom to make a mistake. Java follows a different algorithm. It follows a different philosophy. Its philosophy is let's give less freedom, but less opportunity to make mistakes. So the way that they have their setup is insect, and the new class can inherit from one superclass. So what people can do is they can use interfaces to mimic this behavior, but in the Java environment, right? So sometimes you want to do this. How would you do it? Well, what you would do is create interface 1 and interface 2. And since you can implement multiple interfaces, you have the new class that implements both of them. It's multiple inheritance. But the difference here between this situation and this situation is here you have the possibility of ambiguity, meaning if this class has method 1 in it, and then this class has method 1, let's say using the same name, then when this class inherits from both of them, it doesn't know which one is going to be used. Okay, and then when we're in this situation, if we have method 1 and method 2, hold on, this is off. Am I right? Yeah, I think I'm right. So here we have method 1 and method 2. we know, I'm sorry, method one and method one, since they're both interfaces and you need to implement here, we don't have that ambiguity because the implementation is done in N1, in the new class. So even though they both have the same name and you're overriding in the child class, you know exactly which implementation is going to be run because it's defined in the child class. Up here, you're not sure, right? There's ambiguity. So I think that's about it. Yeah, so that's all I need to say about interfaces. Again, a big topic, one in which there's a lot of discussion, but as it applies to us on the AP CS exam, what we've gone over covers everything that we need to know. Right? So this is just a little bit of background information.